am Agnes by Cervantes, BSN 1A student of Colegio de Santa Lourdes Affiliated Foundation Incorporated, and I am here to discuss to you about taxonomy. So taxonomy is a branch of science in which it is the practice of identifying different organisms, classify them into categories, and naming them. So all organisms, both living and extinct, are classified into distinct group with other similar organisms and given a scientific name. So the classification of organisms have various hierarchical categories. So these categories gradually shift from being very broad and including many different organisms to very specific and identify single aspects. So there are 6 taxonomic categories. There are 8. So these are the domain, kingdom, phylum, class, order, family, genus, and species. So with each step down in classifications, organisms are split into more and more specific groups. So for example, all of the animals in the kingdom Animalia are split into multiple phyla. So phyla is the plural of phylum. So all of these animals in the phylum Chordata are split into multiple classes such as mammals, reptiles, and amphibians. So the broadest category splits all organisms into 3 groups called domains, and the 3 domains of life are bacteria, archaea, and eukaryota. So that was an example. So let us discuss about the kingdom. So kingdom, for a long time, all life was separated into 5 or 6 kingdoms. These include kingdoms such as animals, plants, fungi, protists, archaea, and bacteria. So with new genetic data, we know that some protists are more closely related to animals, plants, and fungi than they are to other protists. This suggests that the protist kingdom could be separated into multiple kingdoms. So thoughts are similar to the bacteria and archaea kingdoms. So next is the phylum. So the phylum, plural phyla, is still a very broad classification. But it splits kingdoms into multiple groups. For example, of a phyla from the animal kingdom is Arthropoda. So Arthropoda, which includes all the insects, spiders, and more, all vertebrate animals belong to one phylum called Chordata. Invertebrates are separated into many different phyla. So next is the class. So class is the next level down. As mentioned earlier, some classes from the phyla Chordata include mammals, reptiles, and amphibians. Arthropod classes includes the likes of insects and arachnids. So arachnids are under the spiders, mites, and scorpions. Next is the order and family. So from class, organisms are placed into an order and then a family. Using grasses as an example from the plant kingdom, they belong to the order Poales and the family Poaceae. So lastly is is the genus and species. So the final two categories are genus and species. The genus and species that an organism belongs are how an organism receives its scientific names. So this naming system is called binomial nomenclature. And was invented by a brilliant biologist named Carl Linnaeus. An identified species is placed into a specific group in each of the categories. For example, the taxonomic classification of human is, the domain of human is Eukaryota, kingdom Animalia. It belongs to the Animalia. Phylum is Chordata. The class is Mammalia. The order is Primates. Family is the Hominidae. So the genus is Homo, because we belong to the Homo, and the species is the Homo sapiens. So to remember the order of taxonomic hierarchy from domain to species, people usually use mnemonics to make it easier. So to remember the classifications, remember this phrase: King Philip came over from Germany swimming. So K is the kingdom, P is the phylum, C is the class, O is the order, F is the family, G is the genus, and S is the species. So that ends my discussion about taxonomy. So I will discuss about how to determine relatedness among organisms using the phylogenetic tree. So humans as a group are big on organizing things, not necessarily things like closets or rooms, but their ancestors. So modern systems of classifications are based on evolutionary relationships among organisms. So that is the organism's phylogeny. Classification system based on phylogeny organize species and other groups in ways that reflects our understanding on how they evolved from their common ancestors. So how do we use, what is a phylogenetic tree? How to read phylogenetic trees and how to determine which species are most related. So a phylogenetic tree is a diagram that represents evolutionary relationship among organisms. So phylogenetic trees are hypotheses, not definitive facts. So when we say phylogenetic trees, it determines their common ancestors. So from their common ancestors, we will branch them to their species. So this is the pattern of branching in a phylogenetic tree reflects how species or other groups evolved from a series of common ancestors. So from the oldest ancestors to the newest ancestors. In trees, two species are more related if they have a more recent common ancestor and less related if they have a less recent common ancestor. So phylogenetic trees can be drawn in various equivalent styles. Rotating a tree about its branch points doesn't change the information itself. So when we draw a phylogenetic tree, we are representing our best hypothesis. So a phylogenetic tree is most likely hypothesis. it is somehow we are guessing their most common ancestors from their species. So, in a phylogenetic tree, the species or groups of interest are found at the tips of lines referred to as the tree branches. For example, the phylogenetic tree has A, B, C, D, and E at its tip. So, the A, B, C, D, and E, which are positioned at the end of the branches, they are represents the relationship between the 5 species. So the pattern in which the branches connect represents our understanding of how the species in the tree evolved from a series of common ancestors. Each branch point, also called internal node, represents a divergence event, or splitting apart a single group into 2 descendant groups. So, when we see the branching, it represents the divergence event, which means a single group has other descendant groups. At each branch point lies the most recent common ancestor. So, each branching point of the phylogenetic tree means it is their most common ancestor. So, all of the groups descended from the branch point. For instance, at the branching point giving the rise to specific A and B, we could find the most recent common ancestor of the 2 species at their branching point. So which species are more related? In a phylogenetic tree, the relatedness of 2 species have a very specific meaning. 2 species are more related if they have a more recent common ancestor. So, the branch that is nearer to the species, that is their common ancestor. So, and less related if they have a less common ancestor. So the lowest branches that the 2 species have is their less recent common ancestor. So here, importantly, there are some species whose relatedness we can compare using this method. So as I've said earlier, phylogenetic trees are just a hypothesis on how to relate 2 or more species from each other by determining their common ancestors. That ends my discussion about the relatedness and determining how related organisms are.